Welcome to the Unit 3, Section 3 video on different forms of linear functions. If you know the slope of a line and the y-intercept, you can write an equation that describes the line. Given that the y-intercept is b and the slope of the line is m, the slope-intercept form of an equation of the line is y equals mx plus b. Any linear equation can be written in slope-intercept form by solving for y and simplifying. In this form, you can immediately see the slope and the y-intercept. So to write an equation given the slope and the y-intercept, first you find or use the slope, find or use the y-intercept, and then substitute the slope and the y-intercept into y equals mx plus b. So in this example, we're going to write the equation of a line in slope-intercept form given the slope and the y-intercept. So if we are given that the slope is negative 7/5 and the y-intercept is 4, we can just take y equals mx plus b and put negative 7/5 in place of m and 4 in place of b. And now we have the equation of the line. If the slope is 0, then we would plug 0 in for m, but there's no reason to write 0x. So we could just write, using the y-intercept, y equals 2. And remember that a linear equation or a linear function with a slope of 0 is a horizontal line. So your y is going to be the same value all along that line. Now, if the slope is 4/3 and the y-intercept is 0, again, we can plug 4/3 in for m and 0 in for b, but there's no need to write the plus 0 on the end, so we can simply write y equals 4/3 x. In this example, we're going to write the equation of the line in slope-intercept form given the graph. So in the graph here, we can find the information that we need. Remember, we need the slope and the y-intercept. You find your slope using rise over run. So our slope in this place is 3 because we rise 3 and run 1. And our y-intercept is at y equals 4. So in this case, b equals 4 because b is our y-intercept. And then we can just plug in 3 and 4 in for m and b and get our equation of our line. For b, we have a slope of rise over run, rise of -1, run of 2, so -1/2, and a y-intercept of -2. So if we plug in m and b, we get y equals -1/2 x minus 2. Writing an equation given the slope and a point requires finding or using the slope, using the point to determine the values for x and y, and then substituting the slope and point into the equation. At this point, you will have substituted everything but b, so you will solve for b to find out what that value is and substitute it back into the original form. So in example 3, we're going to be given the slope and a point, and we're going to find the equation of the line in slope-intercept form. So for the first part of this example, our slope is 4, our point is 5. So in our slope-intercept form, we are going to plug in y equals 5, m equals 4, and x equals 2. And then we're going to solve for b. Once we have what b is, what our y-intercept is, we can take our slope and our y-intercept and plug them back into slope-intercept form. In example B, our slope is -1/5 and our point is 5, -2. So again, we plug all of this into the equation except for b. That's what we're going to solve for. And we just solve our equation to get b equals -1. Our y-intercept is -1. Our slope is -1/5. So we plug both of those into slope-intercept form, and we have the equation of our line. In this example, we have our slope of 0 and we have our point -4, 7. We plug everything into the equation and we very quickly find that our y-intercept is 7. Now we take our slope and our y-intercept, plug them back in, and we find that our equation is y equals 7. Now, think back to the slope and the point that we were given. If our slope is 0, then we know that we're going to have a horizontal line where all the y values are the same. So if all of our y values are the same and negative 4, 7 is on the line, then that y value must be our equation, y equals 7. In this example, our slope is undefined, and our point is 2, 8. Well, we can't plug in an undefined slope into slope-intercept form, but the information that we do have here gives us enough to be able to write the equation on the line. If our slope is undefined, then we're going to have a vertical line. And that vertical line means that we are going to have that vertical line at an x value, and all the x values will be stacked on each other. Okay? So since every x along that line is going to be the same, then we can simply take the x out of our point, which is 2, and write the equation x equals 2. So looking at these two examples, if your slope is 0, then you're going to use your y value, and you'll have y equals 7. If your slope is undefined, then you're going to use your x value, and you'll have x equals 2. Writing an equation given 2 points requires calculating the slope using the slope formula that you were already introduced to, using either point to determine the values for x and y, substituting the slope and point into slope-intercept form, solving for the y-intercept, and then finally taking the slope and y-intercept and putting them into your final equation. So for example 4, we're going to write the equation of the line passing through negative 2, 5 and 0, negative 1. This is just like the previous example, but we have the extra step of having to find our slope. So we use y2 minus y1 over x2 minus x1. We plug in our y2, which is negative 1, our y1, which is 5, our x2, which is 0, and our x1, which is negative 2. And then we solve and get that our slope is negative 3. Now that we have our slope, we're going to plug it in along with one of the 2 points into our slope-intercept form and solve to find our y-intercept, which is negative 1. Finally, now that we have m and b, we can plug those 2 things into our slope-intercept form to write our final equation. You can also quickly graph a line when the equation is written in slope-intercept form. You'll label the y-intercept and plot this on the y-axis. Then you'll identify the slope and label the directions. Positive movements are up and right, negative movements are down and left. Starting from the y-intercept, use the slope to plot a second point. You must use both directions before plotting a point. You must move in the x and the y direction. Remember, if the slope is not a fraction, then make it a fraction by putting a 1 under the number. If you cannot fit the slope on the graph, then use the opposite directions for rise and run. If the slope is positive, the line should be increasing. If the slope is negative, the line should be decreasing when you have your final sketch. So in this example, let's graph the line described by the equation in slope-intercept form. So here we have slope-intercept form. We know that our slope is 4 and our y-intercept is negative 3. So in the graph, we plot first our y-intercept, which is 0, negative 3. And then we did our slope of 4. So a rise of 4, so you go up 4, and a run of 1, so you go to the right 1. And then from that point, up 4, right 1. And you continue until you have enough points to plot your line. For example B, we have a slope of negative 2/3 and a y-intercept of 2. So you start by plotting that y-intercept at y equals 2. And then you can go either down 2 and right 3, or up 2 and left 3. And in this case, you needed to do both of those to get 3 points so that you could draw your line. There's often more than one way to arrive at the same solution. The slope formula can be rewritten into a form known as point-slope form. So point-slope form for any given point, x1, y1, on a non-vertical line with slope m, the point-slope form of a linear equation is y minus y1 equals m times the quantity x minus x1. If you have the slope and at least one point, you can use point-slope form to find a linear equation. Remember, if you are given the y-intercept, you are given the point 0, b. So to write an equation using point-slope form, you'll find or calculate the slope, use a point to determine the values for x1 and y1, substitute the slope and point into y minus y1 equals m times the quantity x minus x1, and then solve for the y to rewrite in slope-intercept form. So we're going to use point-slope form to write the equation of a line in slope-intercept form. So we're given a slope and we're given the y-intercept. Now we could do this by simply plugging it into slope-intercept form, but the directions specifically say to use point-slope form. So we are going to use y minus y1 equals m times the quantity x minus x1. Remember, if you're given the y-intercept, you are given the point 0, 4. So we can plug 4 in for y1, 0 in for x1, and then, of course, negative 7/5 for your slope m. And once you do this, you can distribute the negative 7/5, which leaves us with negative 7/5 x. The second term is multiplied by 0, so you don't have to write it. And then we add 4 to each side, and now we have the equation in slope-intercept form. For the second example of this set, we have a slope of 0 and a y-intercept of 2. So if we use point-slope form, remember the y-intercept gives us the point 0, 2, and the slope is also 0. And when we distribute the 0 to what's in parentheses, we end up with 0 on the right-hand side, and when we add 2, we get y equals 0, or I should say y equals 2. And then in this last example, if we have a slope of 4/3 and a y-intercept of 0, our y-intercept indicates that we are at the origin for our point. So we can plug in 0, 0 is our point, 4/3 is our slope, and we end up with y equals 4/3 x. Now let's use point-slope form to write the equation of the line in slope-intercept form when given the slope and a specific point. So again, we have our x1, y1 from the point, so we plug that into those two items. The slope goes in for your m, as always. We distribute the 4 on the right-hand side, so we get 4x minus 8, and then we add 5 to each side to give us y equals 4x minus 3. When the slope is equal to negative 1/5, and we have a point 5, negative 2, we plug in our x1 and y1, and we also plug in our m, which is our slope. On the left-hand side, we get y plus 2. When we distribute the right-hand side, we get negative 1/5 x plus 1, because negative 1/5 times negative 5 gives us positive 1. And then we subtract 2 from each side to get y equals negative 1/5 x minus 1. If the slope is 0 and we have the point negative 4, 7, again, the process is the same. Plug in your point, plug in your slope. We're going to get 0 times the quantity on the right side, which is just going to be 0, and then we add 7 to each side. Now, if the slope is undefined, just like with slope-intercept form, there's nothing that we can plug in because we cannot plug in an undefined slope. So we simply go to our x value, which is 2, and we get x equals 2 as our equation. Now we're going to use point-slope form to write the equation of the line passing through the points negative 2, 5 and 0, negative 1. So to do this, we have to find the slope first using our slope formula. So we get our slope is negative 3. Next, now that we have our slope, we're going to pick one of our 2 points to put it in point-slope form. And I would go with the second point here, because 0 is an easy number to work with. On the left-hand side, we get y plus 1. On the right-hand side, we distribute the negative 3. We get negative 3x. The second term is multiplied by 0, so we don't have to write it. And then we subtract 1 from each side. Previously, you graphed a line given its equation in slope-intercept form. You can also graph a line when given its equation in point-slope form. Start by using the equation to identify a point on the line. Then use the slope of the line to identify a second point. So to graph a linear equation in point-slope form, identify the slope, identify the coordinate x1, y1 on the line from the equation. The signs are the opposite of what they look like in the equation because remember, in point-slope form, you're subtracting x1 and y1. Plot the point first. Then use the slope to find your directions and plot a second point. Connect with a straight line. Remember, if the slope is not a fraction, then make it a fraction by putting 1 under the number. If you cannot fit the slope on the graph, then use the opposite directions for rise and run. If the slope is positive, the line should be increasing. If the slope is negative, the line should be decreasing. So let's graph the line described by the equation in point-slope form. So taking a look at this equation, we know that our slope is 3, and our point, and this is where you have to be careful, is going to be 1, 1. Because remember, our value follows a minus sign. So we plot the point 1, 1 first, and then you use your rise over run, which will be up 3 and right 1, or you can go down 3 and left 1, and then you can draw your line. In this equation, we have a slope of negative 1/2, and our point is 3, negative 2. Even though it says plus 2, when you see the plus, you have to think minus negative 2. So we plot 3, negative 2 first, and then our slope tells us to go down 1 and to the right 2, or up 1 and to the left 2. And then you can draw your line. The last form we're going to look at in this section is standard form. It is a more general way to express a linear equation. Standard form is the form ax plus by equals c, where a, b, and c are all real numbers, and a and b are not both 0. Now, there are a couple of specific guidelines for writing a linear equation in standard form. The first, the leading coefficient a must always be positive, and secondly, none of the coefficients can be fractions. So to write an equation using standard form, you're going to write the equation in slope-intercept form or point-slope form first. Then remove all parentheses using the distributive property. Multiply the entire equation by the denominator of the fraction you have. Isolate the y term. Add or subtract the x term on each side. And then finally change all signs if the a is negative. So let's write equations in standard form, starting with this one, which is in slope-intercept form. So the first thing we need to do is to multiply both sides by the denominator. We have a 2 in the bottom that we want to get rid of. So everything gets multiplied by 2. That gives us 2y on the left, 3x minus 12 on the right. Then we need to move our x to the other side, and it needs to go out in front. So we have negative 3x plus 2y equals 12, negative 12, because we have to subtract 3x from both sides. Finally, we have to change the signs on everything because we cannot lead with a negative. So negative 3x becomes positive 3x, positive 2y becomes negative 2y, and negative 12 becomes positive 12. So our final equation in standard form is 3x minus 2y equals 12. Now let's take a look at an equation in point-slope form. We're going to start by distributing our negative 8/5 through the fraction, or through the parentheses. So that gives us negative 8/5 x plus 8. Now we need to multiply everything by the denominator. So everything gets multiplied by 5. So that gives us 5y plus 25 on the left side, negative 8x plus 40 on the right side. Now we're going to move our 25 over to the other side by subtracting on both sides. So 40 minus 25 gives us 15. We're going to move our 8x to the other side by adding it to both sides. And since we have no fractions and we do not lead with a negative, we are now finished. 8x plus 5y equals 15. Let's write the equation of the line in standard form given the slope and a point. So if the slope is 2 and negative 3, 1 is on the line, since we're given a point and a slope, then we should probably write this in point-slope form. So we use point-slope form to plug in our values. And then from here, we distribute our 2. And then we add 1 to each side. And then we subtract our 2x from each side. And finally, since we do not want to lead with a negative, we change the sign on everything. So we're now left with 2x minus y equals negative 7. If our slope is negative 1/5 and 5, 0 is on the line, we do have a point and a slope. So point-slope form, again, is the place to go for this. We plug in our values. We don't need the minus 0 on the left. We distribute the 1/5 x minus 5 on the right, and then we multiply both sides by 5 to get 5y equals negative x minus 5, and then we add x to each side, and since we're not leading with the negative, we are finished. Write the equation of the line passing through negative 5, 2 and 0, 3. So in this one, we have 2 points, so we can find the slope by using our slope formula. Plug in our x2, y2, and our x1, y1. Find out our slope is 1/5. And then we're going to plug it into slope-intercept form, because notice that one of our 2 points is indeed a y-intercept. 0, 3 is our y-intercept. So we are going to plug in 1/5 for m, 3 for b, multiply everything by 5 to get rid of the fraction, and then finally move our x to the other side by subtracting it from each side. And then last but not least, we don't want to lead with a negative, so flip the sign on everything to get our standard form. To graph a linear equation in standard form, the easiest method is to graph using the intercepts. So to graph a linear equation in standard form using the intercepts, you're going to find the x-intercept. X-intercepts have a y value of 0, so you're going to plug in 0 for y and solve for x, and then plot that point. Then you're going to find the y-intercept. Y-intercepts have an x value of 0. Plug in 0 for x and solve for y and plot this point, and then connect with a straight line. So we're going to graph the line described by the equation in standard form. So here in A, we have x minus y equals negative 3. Well, if we want to find our x-intercept, plug in 0 for y, and that very easily gives us x equals negative 3. If we want to find our y-intercept, put 0 in for x, negative y equals negative 3, so positive y equals positive 3. So now we have our x-intercept of negative 3, our y-intercept of positive 3. You plot those 2 points, and then you sketch your line. For our second example in this, we again use the same method of finding our x-intercept by plugging in 0 for y. That leaves us with 2x equals 8. Divide each side by 2, and you get x equals 4. To find your y-intercept, plug in 0 for x. That leaves us with negative 4, y equals 8. Divide each side by negative 4, and you get y equals negative 2. So on your graph, plot your x-intercept of 4 and your y-intercept of -2, and then connect using a ruler to get your line. Now, for a shortcut, you can set each variable equal to the constant and solve, but you need to be careful with the negative signs. Now, what if you couldn't solve for the intercepts? So, for example, say you've got 6x plus 5y equals -25. Well, if we go to find the y-intercept by eliminating the y, or I should say the x-intercept, by eliminating the y term, that gives us 6x equals -25. Divide each side by 6, and we get a fraction, okay? Now, it does turn out if you solve for your y-intercept by making x 0, that one does come out nice and clean, but that's only 1 point. We've got a fraction for our x. So the equation in standard form will need to be written in the slope-intercept form by solving for y first. Then you can go and plot it using slope-intercept form by finding your slope and your y-intercept. So graphing a linear equation in standard form by rewriting the slope-intercept form requires subtracting the x term on both sides, dividing the entire equation by the coefficient of y, and then simplifying and graphing using slope-intercept steps. So let's graph the line of the equation that we just looked at, 6x plus 5y equals -25. First, you're going to subtract 6x from each side, and then you're going to divide by the coefficient of your y term, which gives us -6/5 x minus 5. So we have our slope of -6/5 and our y-intercept of -5. Plot your y-intercept of -5, and then you do your rise over run. Now we can't go down, so we have to go up 6 and then to the left 5, and then you plot your point. And then finally, connect your 2 points with your straight line. Let's look at another. X minus 2y equals -4. We subtract x from each side, divide each side by -2, and we get 1/2 x plus 2. Our slope is 1/2, our y-intercept is 2. So you're going to plot your y-intercept of 2, and then you're going to do your slope of 1 over 2, rise over run, up 1 to the right 2, or down 1 to the left 2, and then connect your points using your straight line. Thanks for checking out my video in the Algebra 1 Honor Series. You can subscribe to my channel. I've got the next video queued up for you, and if you need to check out any of the videos in the course, I've got the course playlist for you here as well. Thanks for watching.